Welcome back to the deep dive. Today we are tackling a problem that I know you have faced if you've ever tried to set up a killer home theater or, say, a sports bar.
Oh, yeah.
You want crystal clear 4K video on a screen that is, well, nowhere near your media player.
Right. So you run a massive HDMI cable and get signal dropouts.
Exactly. Or you try a cheap extender and get terrible lag.
It's the classic digital cliff. I mean, it works perfectly until it just suddenly doesn't. And usually the fix involves punching holes in your drywall.
Yeah, or spending a fortune on delicate optical cables. But today we are looking at a totally different approach. We are analyzing the specs of the Zenty ZT-158 IP300.
The IP300, yeah.
It's a decoder that promises to solve this by ditching the HDMI cable entirely. It uses something you probably already have in your walls, standard Ethernet.
Which is the core of AV over IP. We are quite literally turning your movie into data packets.
Yeah.
And looking at the documentation for this Zenty unit, it's a perfect case study.
Because it claims to solve the three big problems of video distribution, right? Quality, bandwidth, and the real killer latency.
Exactly. So let's unpack this setup. Right. You have this ZT-158 decoder. That means it sits the display end.
Behind the TV.
Right. You would have an encoder at your source, like your Blu-ray player, turning the video into those data packets. They travel over your standard network switch, and the ZT-158 catches them.
And turns them back into a flawless HDMI signal. And we aren't talking about grainy security footage here. This thing pushes 4K resolution at 60 hertz.
That is the big headline feature. But if we connect this to the bigger picture, uncompressed 4K video at 60 hertz takes massive throughput.
Way more than a standard 1 gigabit network cable can actually handle.
Right. It simply wouldn't fit in the pipe. So it has to shrink the file.
Needs compression.
Yes. And this is where the Zenty IP300 series has its secret sauce. The source material highlights its use of JPEG 2000 technology.
Wait, JPEG? Like the photos on my phone?
Very similar concept, just applied to video. What's fascinating here is that JPEG 2000 is an intra-frame compression standard.
Okay, break that down for us.
Sure. Most video compression looks at a group of frames and predicts the movement to save space. That takes processing time. JPEG 2000 compresses every single frame individually.
Ah, so it treats the video like a really fast flipbook of high-res photos.
That is a great analogy, actually. By doing that, the unit squeezes that 4K signal down to fit a 1 gigabit pipe without crushing the quality.
Because it uses that 4.2.0 chroma sampling.
Right,
Yes.
exactly. It compresses the color information your eye is less sensitive to anyway.
Yeah.
So you keep the sharp image, but respect the network's speed limit.
Okay, here's where it gets really interesting for me, and probably for you listening if you're a gamer or watch live sports. Latency.
The eternal struggle of digital video.
Right. If I hear the touchdown on the radio before I see it on the screen, I'm out. Deal breaker.
Well, heavily compressed video usually means lag. But since that JPEG 2000 method doesn't have to look at future frames to render the current one, it's incredibly fast.
How fast are we talking?
The datasheet lists the end-to-end latency at just 1 to 2 frames.
Wait, just 1 to 2 frames?
Yeah, at 60 frames per second, we are talking roughly 16 to 33 milliseconds.
That's basically instantaneous to the human eye.
Virtually, yes. It totally eliminates that lip sync issue where the audio doesn't match the mouth moving. Keeps live sports feeling actually live.
That is seriously fast. But usually when you compress for speed, doesn't the audio take a hit? Does this strip out the good sound?
Not according to the specs. Audio data is much smaller than video data, so the device preserves it. It supports multi-channel formats like DTS:X and Dolby Atmos.
Nice. So if you are building a high-end cinema room, you don't sacrifice immersive surround sound just to get the video across the house.
Exactly.
Now, let's dream big for a second. Say I'm not just doing a home theater. Say I own a massive venue and want a wall of screens. Can it handle that?
Surprisingly well.
Yeah.
Because it lives on a network, it handles matrix routing. That means you can send any source to any screen.
So the cable box in the basement plays in the kitchen, or the Blu-ray plays on every screen simultaneously?
Right. And it supports video walls up to a 16 by 16 configuration.
16 by 16, that's 256 screens.
It is massive. And naturally, you need a way to control that chaos.
Which the Zenty system offers, right? I saw they had the ZNet iPad app.
Yes, giving you a visual preview for easy drag and drop, Or for pro integrators, there's a Windows PC configurator or even bidirectional RS-232 commands.
Which ties it right into existing smart home automation systems.
Perfectly. It really democratizes professional video distribution.
Getting low latency, high resolution, and massive scalability just using standard infrastructure.
Exactly.
It really makes me wonder, as devices like this IP300 become the standard, are we approaching the end of the traditional long HDMI cable?
It is a valid question. When your network cable can carry 4K video, internet, and power all at once, the single-use HDMI cable starts looking like a fossil.
Definitely something for you to think about before you drill that next hole in your drywall. Thanks for joining us for this deep dive, and we'll catch you on the next one.